Hey guys, thank you for joining the call. Uh, as we discussed a couple of topics regarding the FortiGate training, we try to discuss the initial configuration, a lot of aspects in the initial configuration. We saw the firewall basics, difference between the next generation firewall, stateless firewall, and stateful firewalls. And we also saw how we can basically take care of the initial configurations of the FortiGates while we try to onboard it on the network. So we're gonna move with the next topic, which is the firewall policies. Uh, Let me quickly share my screen. All right, so there you go. So I'm sharing my screen. I have this lab which I had made last time. The admin 123. Okay, if I do IPA, I still have this IP here. The admin A. Okay, there you go. So I made this lab last time where I have one Linux machine, then it's connected with this switch. It's a basic architecture and it's actually connected with the firewall then, and then firewall is connected to the internet. So what I will do is I will try to check what is the IP address on my firewall here. It should be admin, password is 123 that I kept for it. I'll do the IP address list. Okay, so I see the IP for my firewall. It is 192.168.85.130, and I'm actually getting it automatically because I configured my uh, outbound port, which is the port 2. I configure it as DHCP client. So I do config system interface. I say edit port 2, and what I do show, you can see that it's currently configured as DHCP. So what I will do is I will come here to the firewall using the same IP address, and I try to log in here. I'll show you why you can actually configure the firewall policies, and then we'll move to the basics of firewall policies and all the theory that's associated with it. So I just open the firewall and then I go to the policy and objects, and here it goes. This is the firewall policy, right? So as we already discussed that the primary function of the firewall is firewalling, but before it's a firewall, it is always a router. So that's something that will be taken care of. Now you can see that there is already one existing policy here. It's called implicit deny. It says that everything as a source and everything as a destination with every service, it's always denied. So the reason for it is that there's a beautiful saying that says firewall is an idiot device, which means that as long as you don't tell it what to allow, it will never allow. So that's the reason I have not created any rule here. I not defined any policy. I not told this firewall that what you should allow. So it's gonna block each and everything, whatever tries to pass through it. So that is the first important thing that we actually need to take care of. Let me move to the presentation now. Okay, let me quickly close my screen so that I get to here. All right, so let me share my screen back. Okay, so there you go. So going to the theory part, it says that what are firewall policies? So for your information, it's always that a firewall policy is actually a rule. So uh, some rule that will always try to define uh, what actually needs to be allowed through the firewall. So if I come here and I say it's a rule which tells what needs to be allowed through the firewall. So it's actually the firewall policy which will uh, match the traffic. And once you have the traffic match, we're going to see how the firewall policy actually matches the traffic. And the moment it matches the traffic, it tries to process it according to the policies that you had defined, because every traffic is actually susceptible to the processing. Because if I'm sending packets to the firewall, it has to pass through the firewall, and there are a lot of things that happen within the firewall. Uh, the first process or first decision making is whether you want to accept that traffic or you want to deny that traffic. And on top of it, since you can have the UTM, which is the IPS, IDS running in the firewall, so they're also part of the same firewall policy, but you're going to process that traffic for any of the malicious activities. So uh, important thing is that whenever the traffic actually passes through the firewall, it always makes sure that it tries to find a match through the policies, and then it tries to process that traffic based on the decision making and based on the actions that you had defined within that policy, right? So I'll come to the next page so that we can try to define here what it does is, so the first thing that a firewall policy does is it tries to match the traffic, and once it finds a match, then it processes that. It processes the traffic, and when I say process, it means that it's gonna do the action which is either accept or deny. And the second thing is you want to take the UTM decisions where you look for the packets of traffic and inspect. So that's how it actually happens within the firewall policy. So if I come back, uh, as I already tried to discuss that, uh, your firewall is an idiot device. As long as you don't define the rules, it's always going to deny the traffic. And that's what this policy is there for. It's called implicit deny, and it's present in each and every firewall. We have it here. So this policy says that everything that tries to pass through the firewall will be denied. So important thing again regarding the implicit deny policy is that it has the policy ID of, it has policy ID 0. And what is policy ID? Policy ID is basically an identifier which is associated with each and every policy within the firewall. So every policy is defined, is recognized, is identified with the help of an identifier, right, which is called policy ID. And for the implicit deny, it's always 0. So tomorrow when you're going to do troubleshooting or anything else, at that time what you would need to make sure is that if there is any traffic, that it's the policy which is implicit deny, which has the policy ID of 0. It always means that it's always going to get blocked. On top of it, if I try to delete this policy from here, if I right click here and then try to delete it, you can see that this particular option is grayed out. It means that I cannot delete this policy. So it's implicitly defined there, and you cannot basically get rid of it. Next, what is something that I can edit here? I try to edit incoming interface, outgoing interface, source, destination, action. It doesn't let me to do it. Only thing that I can manipulate here is I say that, okay, if there's any traffic that actually is violating right? Which means that that is getting denied. So when I say violation traffic, I'll come back here. I'll say violation traffic. It is basically the denied traffic. So if I come back here now, you can see that for the implicit deny, it had this log IPv4 violation traffic disabled, which means that anything that's getting denied because of this policy will not be logged, will not be able to see that in the logs, right? But I want to turn it on. I say that, okay, everything that's hitting this particular traffic, that's hitting this particular policy, let it be shown in the log. So I'm going to click OK. Now, next is if I come back here, now what are the components of a particular policy, right? What I do is I'll try to understand this particular thing here. So I'm going to create a policy here. I'll name it test, or I will say LAN to WAN, some policy that basically allows me to come from the LAN and go to WAN. Now what I do is if I go to the topology, my port here is port 1 and my LAN is port 1 and my WAN is port 2. I'll try to keep it here as well. I say LAN, save it, and then I will duplicate it. This is just for your understanding. Okay, there you go. So I'll call it WAN. Now I'm trying to say that I want to create a policy that has incoming interface, because the traffic that will come from the clients, that will come from this Linux machine, right? It will be hitting the port 1. So in that way, port 1 becomes the incoming traffic because it's handing, it's getting the traffic from the LAN and then it throws it out via the port 2. So that way, this becomes the incoming interface and this becomes outgoing interface. The terminology is also like you can call port 1 as ingress interface and the port 2 as egress interface. So I will try to make it here as well. I'll say duplicate slide. I come here, I try to remove this, and then I try to define the, okay, I don't need the rubber. There you go. So I'll come here. I say incoming interface, or you call it ingress interface. So it's an interface to which traffic is incoming. So if I imagine myself at port, if I imagine myself at port 1, anything that will come from this Linux machine is incoming to the port 1. So that way port 1 becomes incoming interface. Now if I stand at the port 2, anything that comes to port 2 will have to leave from port 2. So that way port 2 becomes outgoing interface. So the direction of traffic actually defines what is incoming and outgoing. So let me just write here the outgoing interface now. It's also called egress interface, and it's an interface to which traffic is outgoing or exiting, right? So this is the next thing. Now coming back here, if I go to the firewall now, I'm going to define a policy that allows me from WAN to LAN. So my LAN is port 1, my outgoing interface is port 2. I'm going to create source here. So important thing here is that I can maybe type an IP address of a Linux machine here, but that's something that we don't do in the firewall. You always have to define an address object in the firewall, right? So I'll have to create it. Let's assume that the IP address of this particular Linux is 192.168.1.10. I can color it as well. And then I say that, okay, it's the subnet, right? And you can see that there are a lot of options here. What I can do is I can try to explain these as well right here. Let me duplicate the slide. Okay, there you go. So we come here. I say Control V, and now I try to explain all these one by one. So as long as the address object is subnet, so subnet basically stands for IP net mask object. For example, if I want to define 192.168.1.10 slash subnet mask should be, let's say it's 24. So this way I can create an object which is subnet based, which has the type subnet. And other way I can define an address object is in the form of range. I can maybe create 192.168.1.10 to 192.168.2.12. So this way I have created range of objects, right? And then the other one that you can see here is FQDN. For example, a lot of people want to go any IP address, any website, for example, www.facebook.com, right? So this is a fully qualified domain name, and you can also define an object with the help of FQDN. The other one is geography. This basically contains the regions. So you can contains regions based on geography, right? So you can basically create an object with the type geography within the firewall, and then you say that, okay, say for example, if there are Indian users who want to access the facebook.com, you can always let the Indian region to choose within the firewall policy, and then you say that, okay, this is being allowed to access the facebook.com. Other one is dynamic one. Dynamic. Now the dynamic one here is it is dynamically fetched. So what it basically means is just try to say new slide. I come here, let me remove it. Okay, so there you go. So I'll come here to describe the dynamic object. In this case, what basically happens is I'll pick as basic example. You guys had the Cisco routers or Cisco switches, right? Let's say this is router 2, this is switch 1, switch 2, right? As long as they all are Cisco devices, you can discover them using CDP. So uh, Cisco devices have this property that they are able to identify each other with the help of uh, Cisco Discovery Protocol. That's they exchange some information. Likewise, in the Fortinet, you have a protocol called FortiTelemetry, where multiple Fortinet devices can basically share information. And this actually works on TCP 8013. Now, for example, let's say that this is one device. I call it device A, device B, and device C. You can basically fetch this information from A to B, right, with this particular protocol 8013. And at that time, if you want to fetch some basic object information from type A to from node A to node B, they will be called as dynamic objects on FortiGate. Imagine that this is the FortiGate device here, and this is your uh, let's say this is endpoint security tool. Now what happens is if there is any tag that has been created on the device A, right? As long as this device is integrated with the FortiGate, uh, you can always push those objects into the FortiGate, and later on the FortiGate they show up as a dynamic object. So this is what is actually meant by the dynamic objects. Other one is device MAC address, right? So device MAC address is nothing but the MAC address of the device. So you can actually create an object based on the MAC addresses as well, right? Now coming back to the FortiGate, I say, okay, let me log in back here. All right, so if I come to the, I say create new, let me name it test. And as already said, port 1 is my incoming port. I create port 2. Sources, I want to create an object here, an address. I say PC1. Let me call it uh, ITPC. Uh, let's assume that this is the PC of IT department. Now subnet is, I want to create an address here, and then I say this is an ITPC. Change, I'll color it this one, and here the use case for the color for you guys is that you want to define the color of the address objects, make sure that they belong to a particular department. For example, if this PC belongs to IT department, I can color code, okay, any object on my FortiGate which belongs to the IT should be blue colored, and later on while troubleshooting, if there is any object or maybe any traffic that actually relates to any of the policy or that throws any sort of policy violation, I can say that, okay, this looks like to be from the IT, right? So that's how you basically take help from the color coding as well. Now I'm going to define the subnet here. I say 192.168.1.10/32, and then I click on OK. I'm going to call it in the source. Now the destination is, let me keep it all for now. I want to allow ITPC to access each and everything. Now, again, you can see schedule here. Schedule contains uh, always. The other one is create. I can create one-time schedule here, or I can create recurring schedule, or I can create schedule group. Right? We are going to see it later on. For now, we'll focus on creating the firewall policies, and I'll put it as always. Now, in the service, let me just allow each and everything here. The action says that whether you want to accept this traffic or deny. I say for now, okay, I'm going to accept it. Inspection mode is something that we'll be discussing. This is related to the UTM, while your firewall has this capability of inspecting the traffic. So we'll be having a separate chapter for that. Now this is policy based NAT. Definitely we have to NAT the internal IP address to the external one. So that's why I need to turn the NAT option on here, because only the public IPs are audible on the internet. And IP pool configuration basically says that if you want to NAT it, do you want to use the outgoing interface? For now, I'll say yes, because when we will be discussing NAT in the third chapter, I guess fourth chapter, we will see how we basically can manipulate the options of NAT, right? And the use dynamic pool IP, it's basically the dynamic NAT that you can use, right? Preserve source port. I want to preserve the source port. Protocol options, we're going to discuss this again. Security profiles is again part of the UTM, where you can call multiple features of this FortiGate, for example, antivirus, web filter, DNS filter, or application control, IPS, file filter, and also the SSL option, SSL inspection, which all is actually related to the intrusion prevention system. So your firewall has this inbuilt unified threat management, UTM, which actually is a collaboration or combination of uh, multiple modules which work coherently together in a collaborative way to basically give the output. So this is these are all the security features of this firewall, right? And you can actually you can include all those security features within a single policy. So once the firewall action is defined, you say that, okay, the action is fine for this particular IP address. Let me just try what the traffic is all about. So you go ahead and try to inspect the traffic with the help of the security profiles. right? The next is you want to say that, okay, if there's any traffic that hits this particular policy, I say that, okay, I want to log all the sessions, right? There is one more option of security events. So security events basically is your IPS or UTM events, right? So there are two types of events. One is uh, firewall action and other one is security action. So this is really important. When it actually comes to the firewall action, it's always based on the IP address or MAC addresses that you want to allow through the firewall policy, right? But when you try to inspect the traffic and then you get to know that, okay, this particular source IP address were allowed, but later on it was UTM which actually blocked this. So at that time the security action comes into the picture. So I'll come here and I'll try to demonstrate it here as well. So I'm going to say new slide. All right, so this will go away. This will also go away. So there you go. So we just tried. We saw security action, and the other one is firewall action. So this is defined and matched first, and this is defined and matched after firewall action. Right, so this is really important here. This basically represents your UTM action. And what is UTM? It is collection of multiple modules, right? We're going to see it, for example, IPS, DNS filter, you have web filter, etc. And this one is your firewall action, right? And firewall action will basically do the things based on source IP address, destination IP address, and the destination port. So this is the difference between the firewall action and the security action. The firewall action is determined with the help of these three things, and the UTM action is basically determined by the multiple modules which work coherently in a collaboration to see which of the traffic is actually trying to pass through the firewall. If they all try to inspect it, right, and then they come with a disposition saying that, okay, this is a good to go traffic, right? It's not malicious, it has not a bad rating. So that one is defined by the UTM action, right? Now coming back to the firewall policy, I'm gonna log each and everything related to this particular policy. Another one says that generate logs when the session starts. I don't want to turn it on because once the session is installed within a firewall policy, within the firewall, then only I want to log that. It's not like I get this in and say that, okay, the session has started, now let me try to log it. No. Next is capture packets. I don't want to do that for now. The other one is comment. So it's always better that when you work in the production, if you have any ticket number or maybe any firewall request that was raised by client, you always come here and put the ticket number, right? Ticket number with the date, because later on, while you try to audit the things, this helps when you do the audit of the, right? So this will always help you if you put the ticket number and the date here. Now what I say is I'll click on OK. Now I have a firewall policy in place. It allows me from port 1 to port 2. You can see that I have for now kept the interface pair view here. So I'm getting the policies based on the interface pairs. I can use it. I can see the help of sequence as well. And why is the sequence? I can come here to the gear option and I can turn the ID on as already discussed, that ID is basically the identifier which uh, identifies, or which basically helps the kernel to identify and recognize a particular policy. Now, next important thing is that this whole particular policy actually works in the form of AND operation. So I'll try to demonstrate this as well here. If I come here, go to the new slide, try to remove this, and I try to remove this as well. Now, every column in the firewall policy, every column in firewall policy is ANDed with each other. So there you go. So if you have multiple columns of a firewall policy, right? So it's like this. For example, this was incoming interface, right? This was outgoing interface, and this was your source, this was your destination, this was your service, which is nothing but the destination port, this was your NAT, right? And this was your UTM. So what you say is, can I change the color here? Insert, okay, draw, change the color. All right, so there you go. So incoming interface, if it actually matches, so these two basically represent your route lookup. So this is nothing but route lookup. Okay, we forgot the one thing, that is action. Right, so incoming interface and outgoing interface. Say for example, if this is your firewall and you're hitting the incoming interface, this is port 1, and you want to leave from port 2, right? The moment you hit here, your firewall will receive the traffic, and then it says it does a route lookup, and that's why you say that your firewall is first a router and then it's the firewall. So it does the route lookup, and then if it has the route available, right, and then it says that okay, I can just leave this traffic from the port 2. So your incoming interface, outgoing interface, along with the source and destination basically is your route lookup, right? Next is based on the source, destination, and action. If all those are ones, say for example, you have the incoming interface defined in the policy, you have outgoing interface defined in the policy, you have source defined, which your traffic tries to leave from the firewall, it is present in the present as a source within the firewall policy. You have a destination called within the policy where you actually want to go, and then your action is accept, which is high. I call it 1 here, and you also have allowed a particular destination port here as well, that is also high. And if it needs NAT, right, your NAT is also present. And then when UTM tries to inspect the traffic, that also says that okay, this is a good to go traffic, so this is the disposition of your firewall policy, that it will be allowed, right? If anything here becomes 0 by any chance, then your whole policy will become 0, and that at that time it will not be mapped. So when you're able to get the 1 here, it means it's a match. If you get 0, it means no match. And then you basically go down and try to look for a different policy. So this is really important here. I'll try to demonstrate it here as well. Okay, not like this. Let me delete this and come to the new slide. So if your firewall policy columns if anything is not present here, say for example, incoming interface or outgoing interface, source, destination, uh, this is service, right, NAT, action, and UTM, right? If anything becomes zero by any chance, right, it means the policy is not matched, and then your firewall basically tries to do a top-down approach. So it tries to look for a match at the first policy, and then it goes down one by one. So this is called top-down approach. And if it doesn't find any policy, then eventually it's going to meet one policy, which is your implicit deny. And that's why it ID 0, that's why it drops the packets, because it's implicitly denying each and everything. So this is the concept of firewalling here. I will come back here. I try to log in. Yeah, so let me come back to the slide now. So there you go. So you have these components of the policy. You have interfaces. You can also club them later on. We're going to see that as well. You have addresses. You have addresses based multiple types of addresses. For example, we saw quite a few of them. The first one was based on subnet. The other one was, here it goes. It's here. The other one was IP range. The other one was FQD, and you have geography-based subnets as well. You have dynamic objects, and you have device MAC addresses as well. Now you all also see here the users. So you can call the users in the particular policy as well, right? So we're going to see this in the user-based policies. For now, we don't create a users here. Then the next thing is internet service databases. Now, what is internet service database? Let me come here. Now, what I say is, I say that there's a user who wants to go to Office 365, which is nothing but Microsoft Office 365. Say, for example, there's a user, right? He's accessing PC and he's sitting behind the firewall. And his requirement is that he wants to access Office 365. And the moment you say Office 365, it means there are a lot of URLs, FQDNs, IP addresses, protocols, and services, right? So it's really hard for an administrator that he can create all these objects here on the firewall and then allow access to the to this particular PC to the Office 365. So in that case, what Fortinet does is Fortinet says that I have for the internet services like Teams or Office 365 or Skype or TeamViewer or any of the internet services you can remember, for example, Facebook or AnyDesk or maybe YouTube. So if you specifically want to allow users to all these internet services, you don't have to worry about the FQDNs, IP addresses, protocols, and services. So what Fortinet does is it says that I'm gonna bundle all those and put them here, and then I call it ISDB, which is nothing but Internet Service Database, right? So this is how actually goes. So this is basically nothing but a collection of FQDNs. It is IP addresses, and you have protocols, and you have services, right? So this is how the FortiGate actually takes care of this. Now, what happens is if you want to say that if you say that I have this PC here, it has to go to Facebook only, and I don't want to allow anything else, right? You can create a firewall rule and say let PC1 go to the Facebook ISDB, right? So that's how it actually goes. Now the thing is, why does this FortiGate actually fetch these particular internet databases? So important is that the FortiGate is always in communication with the FortiGuard, which is called FDN, from where it fetches the latest ISDBs. So it is job of the FDN to prepare and update ISDBs, right? And then every day, FortiGate, if it's a licensed one, it will just fetch all those ISDBs from the FDN so that when a user tries to access anything from the anything related to the Microsoft Office 365, he can easily access it. And on top of it, if there is anything just that changes in between, that user still has access to it because FortiGate always gets the latest DB of these ISDBs from the FDN. So that is the definition of FDN. If you want to check uh, where you can find the FDN, it is actually part of the FortiGuard configuration. So this is something that you can check in the you can check this in the FortiGate. If I come to our FortiGate and I want to see here what is the configuration for this ISDBs. I say config system FortiGuard, and then I do show. You can see that, and if I do show full, so here it goes. It says set update FFDB enable. So set update FFDB enable means that your FortiGate is capable of getting the updates of the ISDBs from FDN, right? So this is really important here, and this is default configuration, right? It is enabled by default. Okay, so we have created one policy here, which allows the anything that's uh, behind port 1. We have defined one source here, ITPC. It's allowed to go to the internet, and it leaves from port 2 here. All right, so that's all for today. Next, what we are going to see is we'll try to create this lab here complete. We'll try to define some VLANs and the switch and define the IP address for this Linux machine so that it can go to the internet. Thank you so much for your time. We'll continue with this in the next lecture.